In this video, we'll look at another example of using the shell method, only this time we'll skip all of the explanation of the formula and we'll just go right to using the formula for the shell method. So here we have an example where we wish to find the volume of the solid generated by revolving the region bounded by the x-axis, x equal 2, x equals 6, and y equal x minus x squared plus 8x minus 12 about the x-axis, or sorry, the y-axis. So we're going to revolve it this way. So I'll have a picture of what the object looks like here momentarily. But let's take a look at a video that's just like the one we had done before, also from mathdemos.org. So once more, we'll slice this vertically. Then we'll have our shells that are the approximations here. So the idea is still that we're using these shells to approximate the volume as we slice things up. Alright, let's go ahead. So again, you'd still have several shells. So let's think this through again, where this time what we'll do is put a typical shell or a typical rectangle here that's going to be rotated around for our shell, just as was done at the beginning on our video, and we'll do that in order to help us illustrate our shell that is used in our volume. So look at your formula for volume. It's integral from a to b of 2 pi shell radius shell height dx. So all we have to do is figure out the shell radius and the shell height. So we have integral from 2 to 6, because that's where our region goes, from 2 to 6, of 2 pi times the shell radius. Well, what is the shell radius? Look back over here again. The shell radius is the distance from our axis of revolution to our element of our shell, and that's the x distance. So that is x as we have there. So your shell radius there is x. Then what about your shell height? Your shell height then is again the height of your curve there at that particular value of x, gives us that height of the shell. So that's going to be your minus x squared plus 8x minus 12, and then we have dx. So again, integral from a to b, 2 pi, shell radius, shell height. So I want to pause for just a moment and say what the shell radius and shell height are before I actually talk about working that integral. When we revolve about the y-axis, our shell radius is x, and our shell height is f of x. If we revolve about the x-axis instead, everything switches, so that your shell radius is y, and your height is whatever your function of y happens to be. So this is the opposite. We're actually integrating with respect to x when we're revolving about y, which is the opposite of doing things for disks and washers that we had done before. Alright, so back then to our integral. You would have the, and I'll go up here for room, integral from 2 to 6, 2 pi times, multiply your x through, it's a minus x cubed plus 8x squared minus 12x dx. So you wind up with 2 pi times a minus x to the 4th over 4 plus 8x cubed over 3 minus 6x squared from 2 to 6. Do all your arithmetic and you wind up with 256 over 3 pi cubic units, or approximately 268 cubic units. And that's the way these run. In a separate pencast, I will show you how to do this when we slice the other direction.